Hey guys, this is Miss Walworth here to do a quick review with you of the biochemistry lessons that we've already done in this unit. So what we've been learning about is the chemistry of life. That's what biochemistry literally means. You have the bio and then the chemistry. And so this is what everything is made of in the whole universe and how those chemicals keep things alive. Why we're learning this, besides the fact that it's really awesome stuff that I'm supposed to teach you, it's really important because this is what everything's made of. The whole planet and everything on it, it's all made of little tiny atoms that you need to understand. Your brain chemistry, how you feel and your mood and any medications that you take, you're messing with the chemistry of your brain and your whole body. The food that you eat has a lot to do with breaking down the chemicals and then your body using that for energy. So how we've been learning this is working in groups so that you can learn at your own pace and whatever way works best for you. So we've had QR codes linked to videos and songs and pictures. You also have textbooks and plastic models that can be very helpful. And how you'll be tested for this unit is a big test, so we'll see how much you learned since we took a pre-test a few weeks ago. You also have daily goal tracker assignments. So after each lesson you have a little quiz to make sure that you learned what you needed to learn. So lesson 1 was an overview of the atomic structure. So you need to know what everything's made of, and this especially is basic knowledge for any of your other science classes. And there's lots of new technology with nanotechnology that is super crazy, where you could insert robots inside of your body or have little quantum computers that are just one atom in size. So because of all that, you need to know what an atom is, its basic parts and arrangements. So you worked in groups, and at the end you did your goal tracker of being able to draw and label your own model of an atom. You have this diagram on your note sheet that we're supposed to be labeling. Parts of an atom, you have this stuff inside of it here, and then you have these little things floating around the outside. So you kind of have a middle and then the parts on the edge. So you should have labeled that this was the nucleus in here, this middle part. It's made of protons and neutrons. It doesn't matter if you switch those on your graph, just so you know that they're both in there. It doesn't matter if you call the blue ones or the red ones a proton or neutron. You also have electrons on the outside, so these are the little particles that zip around the outside super fast. We also are supposed to find the charges, so electrons are negative. Protons are positive. You remember P for positive. They've got a little T in it for positive proton. And then, since you have positive and negative balancing each other out already, the neutron has a neutral charge that we just call 0. So there's a table in one of your questions where we talk about the charge and location of each of those subatomic particles. So everything we just talked about, we just put into a table. The next lesson, after you finished 1 and drew your atom on your assessment, 1.5 was all about isotopes. So you need to know how scientists find the age of really old stuff, like dinosaur fossils and different rocks. And if you've ever wondered, like, how do they come up with these crazy numbers that this dinosaur lived 5 million years ago? In this lesson, you'll learn about isotopes and find out how scientists find out those numbers. So you did this with your groups also, and in the end you were asked to describe what an isotope is. So look at these diagrams for a minute here. You have up at the top different isotopes of hydrogen up here, and then down below it you have carbon isotopes in this one. So what is the only difference between any of these things? The hydrogen has 1 proton, 1 electron. This one has 1 neutron, this one 2. And then carbon down here, you've got 6 electrons in all of them, 6 protons in all of them, but what's changing is the number of neutrons. Carbon 12 only had 6, carbon 13 has 7, and carbon 14 has 8 neutrons. So all an isotope is an atom of an element that has a different number of neutrons. they're also considered radioactive when they're unstable. So some of these neutrons are just kind of flying out of the atom. So scientists use that to find the age of old stuff, like rocks and fossils. Because something like carbon-14 with those 8 neutrons is radioactive and unstable. So they'll fall apart after a certain amount of time. So let's say there's a T-Rex and it dies in a tar pit. There was all of its carbon-14 in its body because it was alive. As soon as it dies, that carbon-14 starts decaying. So the neutrons fly off. It turns into carbon-13 or carbon-12. And scientists have figured out that half of the carbon-14 will change after 5,730 years. So between that span of time, half of it's gone. In another 5,730 years, half of that carbon-14 is gone. So if there was 25% of your carbon-14, you could find out that whatever you're investigating is around 10,000 years old, 11,460 years old, if there was exactly 25% of it left. So you can think about this into your explanation of the world. What do you think about this process? Maybe we need to do a little more investigations, but I think it's really interesting to know how people come up with these ages. So lesson 2 was where it starts to get really good. This is the octet rule. So you need to know which elements react with each other. You need to know it for an EOC in here, your life in general, and definitely the zombie apocalypse. When we're stuck in a survival settlement, we can't have people just mixing explosive chemicals because they didn't pay attention in chemistry. So we'll learn what makes atoms react together or not. So we'll make models and do some stimulations on the iPads, and then you'll be asked what makes an atom happy and what's the octet rule. You have a table kind of like this on your note sheet where you're supposed to draw these 4 atoms. You could do it multiple ways. Each one of mine shows a different way that you could have drawn it. So we have carbon, we have 6 electrons, 6 protons, 6 neutrons. So we have 6 electrons on the outside. This first ring has 2, only holds 2, and then in a second shell we got 4 electrons because atoms have layers like ogres and onions, and it can only fit a certain amount in each layer. So neon, we have 2 electrons on the inside and then 8 on the outside because there's 10 total. Sodium, we start a whole 3rd ring because there's already 8 full on that second ring, so the 3rd one only has 1 electron. And then fluorine has 1 less than neon, so it's got 9 electrons, 2 on the middle, 7 on the outside here. So we talked about what makes an atom happy. It says to have a full outer shell of electrons. So in this case, neon is happy because there's only 8 electrons that can fit in that second ring, and it has all 8, so it is very happy. Carbon, however,